It's supposed to be a 130-volt power supply. Why is it putting out only 90? Hi, I'm Kevin. Welcome to my cave. I thought that I was done with the series on the vintage Tektronix oscilloscope that I've been working on, because in the last episode it was apparently working perfectly. But then I was working on a fun project with it, and suddenly it went all wonky. The display brightened and dimmed, the horizontal range was tiny, and the vertical didn't respond at all. So I have more troubleshooting to be done. Time for the safety briefing. Back in a moment. This video depicts servicing live equipment containing a cathode ray tube. The equipment contains potentially lethal voltages. These voltages may persist even after AC power is removed. A CRT in operation, particularly an older one such as is present in this unit, may emit harmful amounts of X-ray radiation when in operation. A CRT also contains a high vacuum and may implode violently if broken. Please use appropriate personal protective equipment and do not attempt to service units like this if you are not trained to deal with the hazards. Oh, and before I continue, let me warn you. This whole video series is a what did rather than a how-to. I make a bunch of mistakes along the way, and at the time of this filming, I have no assurance of success. Unfortunately, I didn't capture the oscilloscope's misbehavior on camera. But reasoning that on this old equipment it's usually a cap in the power supply, I pulled the supply out and probed all the voltages with meter and oscilloscope. Sure enough, the unregulated supply for the plus 130-volt line was swinging all over the place. Its filter capacitor must be open. Of course, that capacitor is the one oddball one in the power supply that's in a 1-inch can rather than an 1 1/4 one. The adapter boards that I had made last time will be useless. A short KiCad session produced a schematic and a board layout for a new adapter to fit this cap. The 3D model looked good. I sent off to the board house to have a few of those made. I'd ordered a replacement cap, as usual with a somewhat higher voltage rating. This time, I also ordered some brass pins for the adapter, rather than doing an ugly hack with snippets of 14-gauge wire. Then came the struggle of getting the old cap out, even using lots of flux, applying low melting point solder, trying a solder sucker and a bunch of snippets of braid, and all with an old-school 120-watt soldering gun. I couldn't get the first lug clean enough to wiggle. That aluminum can is just too good a heat sink. I tried cutting away the lugs, but they're made of a material hard enough that my flush cutter couldn't handle it. So I broke out the Dremel, and using my smallest diamond burr with lots of oil to cool it and carry away the dust, I ground away the 3 lugs closest to the edge of the board. Unfortunately, the tool slipped in my hand a couple of times, and I'm afraid I might have damaged some of the foil on the board. With the 3 nearest lugs cut, putting heat on the 4th one dropped the cap right out. Then I was able to pull the stumps of the lugs and clean up the excess solder with wick. That went pretty fast. Please indulge me for a brief interruption. As longtime viewers of this channel know, it's always free to all comers. Nothing is ever paywalled. But I do make one request of my viewers, that you take care of one another. To that end, all my ad revenue goes to charity. The current featured charity is World Central Kitchen. It has a sole mission: bring freshly prepared meals to those living in the wake of a natural disaster, a man-made emergency, or a humanitarian crisis. It is a team of food first responders, mobilizing swiftly to get meals to the people who need them most. Its model of swift action in time of need, leveraging local resources and adapting in real time, reflects a belief that a nourishing meal in a crisis is much more than a plate of food. It's hope, it's dignity, and it's a sign that someone cares. At the time of filming, World Central Kitchen has served over 600 million meals in communities all over the world. I know that Kevin's Cave people are a generous lot who believe in taking care of others. Won't you help out today, using the link up here or down there or at any rate somewhere nearby? Thanks so much for your generosity. And now back to the video.
A few days later.
Then when the parts came in, I was able to solder in the pins. Cut them flush. And solder the new cap in place. Unfortunately, when I inspected the board, I saw I had indeed cut traces with the Dremel, so I had to repair them. I couldn't find a camera angle where both you and I could see what I was doing, so bear with the still images for a bit. I kind of thought it was more important for me to see. I cleaned up the grinding dust, laid out a bead of tacky flux along the broken traces, and stuck little bits of bare wire on them. Then I went in with the iron and tacked them down with solder. I made it a point to use solder with a melting point of 221 Celsius, so I can later solder in the cap on this same pad with 193 Celsius solder. That was the next step. I soldered the cap in place, and then beeped out the connections to make sure my repair to the broken traces had held. So far, so good. Have I fixed the problem? Nope. Scope is as dead as a doornail. Well, let's see if I fixed the immediate issue. The manual says that none of the power supplies will work if negative 50 volts isn't right, so I'll start with probing its test point on the regulator board. It's a little high. I'm not going to worry about trimming it until everything else is fixed. Let's see about the other supplies. The supply that should be positive 130 volts is reading 2 volts or so. The positive 50 and positive 15 supplies are each showing about 0.6 of a volt. The positive 5 is showing about negative 0.4. Negative 15 is showing negative 1.7. But negative 50 is more or less happy. It's the only DC supply that's working. Have I broken the rectifier board totally? Let me get in and probe it. I had to switch to a piercing probe on the meter to get through that conformal coating or lacquer or whatever it is that's all over the board. But once I do, C813 and C814, the unregulated supply for the plus 15 volts, are looking correct at a little over 28 volts. Same with C811, the filter capacitor for the negative 15 volt supply. That's the one we replaced last time. C806, the one we just replaced, is showing only 90 volts. That can't be right. It's the storage cap for the 130 volt supply. Let me come back to that, though, and finish up with the others. C821, the one for the 5 volt supply, is showing about 14. That's good. C809, the one for the 50 volt supply, has almost 70 volts. Okay. And C808 for the negative 50 volt supply also looks good. It ought to, since we already see the negative 50 is working. But what's up with that 90 volts on the 130 volt supply? Is the new capacitor open? Well, when I get a scope probe on it, I'm seeing negligible ripple. Nothing like what I saw with the bad cap. even when I switch to AC coupled input at 5 volts per division, it's pretty flat. Can I get any insight from the schematic? The scan that I have is almost illegible for the relevant part of the circuit, but the commercial version of the scope has the same circuit in it. And it's a little interesting. The bottom of the capacitor isn't at ground. The schematic says it's plus 40 volts. So this unregulated supply must be producing about 90 volts. And there's a feedback loop in play here. If the 130 volt signal is at its nominal level, this voltage divider will divide it down to 49.6 volts. If there's an overvoltage, this diode will clamp it to 50 volts to keep Q852 out of avalanche conduction. Q852 is a very high gain inverting amplifier. At 49.6 volts, the transistor is just barely beginning to conduct. If the voltage at the base is a little higher, the transistor cuts off and R853 pulls the collector down, limited only by the 43 volt zener here. If the divided down base voltage is a little lower, then Q852 goes into heavy conduction and pulls the collector voltage up. Q850 is an emitter follower that buffers the collector voltage, and its output goes to the bottom of the capacitor. The end result is there's a feedback loop that lifts the bottom of the capacitor up so that its top stays at 130 volts. But we know the 50 volt supply is not putting out, or at least its output isn't getting to everywhere it should. So the 40 volt feedback line will be stuck near ground and the 130 volt rail will be stuck 90 volts above it. That's exactly what we're seeing. But what's with the 50 volt supply? Well, its unregulated input is all right. We measured that. And its current sources are driven from plus 130 volts, and even plus 90 should give enough collector current for, wait a second here. Plus 130 and the rest of the scope is dead. Oh! Plus 130 is coming from the other side of this fuse. Is the fuse blown? I'm seeing the 90 volts on the back of it, and bupkis on the front. I think it's open. Let me pull it out. I don't see the fusible wire in it, but the fine wire in a 150 milliamp fuse can be hard to spot. Let me put it on an ohm meter. Yep, it's blown. But why? Well, I could have accidentally shorted something out when probing, or there could be a faulty circuit downstream, or the open capacitor might have caused an overvoltage that made something draw excess current. There might even be a crowbar circuit somewhere to protect against an overvoltage by blowing the fuse. I'm going to have to troubleshoot it, but first I have to get a replacement fuse. In the meantime, let me do a quick check with the power off and see what kind of resistance there is from plus 130 to ground. About 9K in the first second, rising nearly to 10K as the test current from the ohm meter charges whatever capacitors there are downstream. If we applied 130 volts, that resistance would draw about 13 or 14 milliamps, nowhere near enough to pop a 150 milliamp fuse. So at least there's no hard short anywhere, and there's more troubleshooting to be done. But I can possibly get away with replacing the fuse and not have the new one blow immediately.
A few days later.
The fuses have come in. I'm going to start by removing every possible load from the power supply. I can remove most of the downstream loads by unplugging their wiring harnesses. I need to leave the main interface board in place, because the power supply uses remote sensing, but I can remove all the plugins from it. Then I can plug in the replacement fuse and apply power to the scope.